Okay, for homework 1211, I'd like you to copy all this work down and listen to me as I explain it. So here we go. Sum of two numbers. Sum is adding two numbers. I'm going to make x my first number, y my second number. I could have used any variables I wanted. Is my equal. So x to me is going to represent the first number. So when I graph it, it will be set up for the x and y axis. The second number is going to be y. So again, when I graph it, it will be set up on the x and y axis. The first of two equations, systems always two equations, is x plus y, the sum of two numbers which I don't know, is equals 9. My second equation, difference is subtracting, same two numbers, x and y, is equal -3. So this one would be x minus y equals -3. Easiest way to solve this system of equations for x and y is to eliminate, stack them as is, and add straight down. If one of the variables is opposite and cancels away, that will leave you just solving for the one variable that's left. So 2x, 6 from those two numbers, divide by 2, gives me x equals 3. Take that 3, plug it in to one of my equations for x to solve for y. So that would be 3 plus y equals 9. To solve for y, just take away 3 on both sides, and that gives me y equals 6, which makes sense. With y is 6, the second number, and x is 3, the first number, cat. That would be 6 plus 3, 9, and 6 minus 3, or I'm sorry, 3 minus 6, -3. So 3 plus 6, 9, 3 minus 6, -3. I want you to solve this by graphing as well. So my first equation, x plus y equals 9. My second, I want you to be able to algebraically solve these for y. So minus 1x minus 1x gives me y equals -1x plus 9. My second equation, a little bit harder. Take away x. Make sure you bring down the negative with the y. Negative y, bring that down, equals -1x plus 3. Oh, I'm sorry, minus 3. Divide everything by -1 to make this y positive. Gives me positive y equals 1x plus 3. So if I graph those should match up at this coordinate 3, 6. So over up to 9 on the y-axis, y-intercept, -1 over 1 is my slope. So over 1, down 1, over 1, down 1, left 1, up 1. Draw your line. Label that line for me. That line is -1x plus 9. My equation in red start at 3 on the y-axis, and then from there 1 over 1, right 1, up 1, right 1, up 1, right 1, up 1. Draw your line through them. For solving a system of equations, I'm looking for only that point where they intersect. That point which matches up is 3 for x, the first number, and 6 for y, the second number there. Again, this is my x-axis, x, y-axis. Okay, the next problem is the same wording, but I'm changing up. It's not is, it's changed to is at most, inequality, is at least. So these are inequalities. Horse, horse. So for these, same two variables, sum of two numbers, I'm going to use x and y, but at most is written as the less than or equal to symbol. At least is the more than or equal to symbol, and I'll try to explain that. So two numbers, a sum of x plus y, is at most less than or equal to 9. And it's got to be less than or equal to for at most. If I could get that to work. So back to this problem right here, it is x plus y less than or equal to y. That's going to be at most. At most means 9 is the highest number that these two numbers can add up to, or anything less. Cannot be over 9. So is at most is less than or equal to 9. These numbers add up, can be no more than 9, less than or equal to. My other equation is x minus y, difference between these same two numbers, is at least -3. I write that more than or equal to because I need these two, when I subtract them, to be -3 or more. -3 is the lowest value I can have. Anything bigger than -3 is okay. That's what it at least means. So to solve these for y, to get them ready to graph, -1x minus 1x, bring this y down, gives me y less than or equal to -1x plus 9. Inequality tells me what the line looks like, solid. It is less than, so I'm going to shade below this blue line. Less than means shade below. So up to +9 on my y-axis. Over 1, down 1. So +9. Over 1, down 1. Over 1, down 1. Same way to graph. That will be a solid line. And less than means all the points below that line are satisfying this inequality. Any coordinate below this line, 0, 0 works, 0 plus 0, 1, 1 works. All these coordinates, including the ones along this line, underneath here, less than, will satisfy this blue inequality. To solve the other one, a little bit harder, take away 1x. Make sure you bring down -y more than or equal to -1x minus 3. Divide both sides by -1. Remembering that dividing by -1 flips your inequality. You have to know that. Dividing by a negative number changes the direction of your inequality. So this ends up being y switches from more than or equal to less than or equal to 1x, switch it. Make sure you switch 1x plus 3. Inequality is a solid line. Less than means shade below. So when I graph that line up to 3 on the y-axis, over 1, up 1, over 1, up 1, over 1, up 1, draw my line through them. I know that this shaded zone is below this red line. So anything below this red line will satisfy this inequality. Any coordinate under here for x and y, 0, 0, 0, less than or equal to 0 plus 3, that is true. So when I shade them both, I see that the intersecting part is this little part right here. So I'm going to fill that in. Alligator, alligator. So any point in this region as a pair will be both, when I add them up, less than or equal to 9, or when I subtract them, more than or equal to -3. I'm going to choose the point 0, 0, the origin, and 2, 2. So my two combinations 0, 0 will both add up and be less than 9, and subtract and be more than or equal to 3, and 2, 2. To check it, just going to plug them in to both inequalities to see that these coordinates will satisfy both. So check, plug in 0 for x, 0 for y, gives me 0 plus 0 less than or equal to 9. That is true. When I plug in 0 into the second equation, I get 0 minus 0 greater than or equal to -3, and that is true statement 2. 0 is more than -3. And then plugging in 2, 2 plus 2 less than or equal to 9. 4 is less than 9, that is true. And when I plug in 2 minus 2, that gives me another true statement. What this graph's also telling me, bigger combinations I could use. These numbers I could use 3, 6. I could have used 3, 5. I could have used 2, 5. I could have used 4, 5. If I wanted a large amount of x's first number but smaller y, I could have used 8, 1. Could have used 7, 2. If I wanted the most y numbers, I would have chose this one at 6, 3. Again, depending on what kind of values you're looking for, any of these in here will apply. Good luck.